Between the last lecture and the presentations that you're seeing in class, I hope we are pretty much able to convince you that meteors are a serious threat to life on Earth. So the question always comes up, well, what do we do about it? Can we stop this in some way? And there are various solutions that have been proposed, and some of them are better than others. In this lecture, we're going to look at a few of those. Now, the one that you've probably heard of because it occurs in various Hollywood movies is hit the thing with a nuclear bomb, blow it up, and then you don't have to worry about it anymore. You have probably even seen Armageddon with Bruce Willis, which is a very inaccurate movie as far as science goes. There was another movie that came out the same year with Elijah Wood, and that's called Deep Impact, and that's one of the most scientifically accurate movies there is out there. But in both cases, they consider the option of hitting it with a nuclear bomb. Now, the one in Armageddon, they specifically say in the movie, has a size equal to Texas, and so I invite you to imagine what would happen if you hit something the size of Texas with one nuclear bomb, even if you burrowed under the surface and, stuck the nuclear bomb down underneath the surface of the Earth, what would happen? And I think you can easily imagine that one nuclear bomb would not have much of an effect in that case. So not going to be effective at all. Of course, most asteroids are not as big as Texas. Most of them are only a couple of kilometers across at the most, and that's, if we're talking about a, wiping out human life kind of thing, that's what we would need to worry about. And yes, with a single nuclear bomb, you could cause some serious damage to something that's only a kilometer or two across. So it might actually work. If you did it in time, you might manage to prevent an impact. Of course, the problem, and this is what happens in deep impact, is that what you tend to do is you break it into smaller pieces, and the smaller pieces still hit. So, okay, smaller is better than bigger, perhaps, but so we're taking something and splitting it into two different locations, and that's still not very good. You have a homework problem where you imagine splitting a 1 kilometer asteroid into 100 or into pieces that are 100 meters across. Now, 100-meter ones are still big enough that, like, if one of them hits, it's like hitting that location with a nuclear bomb. So instead of hitting in one location with something that would give you an effect like Chicxulub, now you're taking 100 locations on Earth and hitting them with nuclear bombs. Well, okay, you can debate if that's better or not. So there's still a problem. Obviously, we have the technology to do this. We could, if we were desperate, make this happen. You would probably not hire some random guys. You would hire NASA with professional astronauts who know what they're actually doing in space. We have the ability to do it, but there's no specific plans about what we would do if it came to that. And so it would require mobilization on a very, very fast rate. But if life on Earth is at stake, maybe we would do that. The problem comes in, other than the issue of splitting it into pieces and having those hit the Earth, there is a political issue here. Because the United States has nuclear weapons, we have NASA, that's all great. We could do it. But there's other countries that also have nuclear weapons and the capability to do it, like Russia. China is coming very close to being able to do that. And you start getting into issues of, well, would you feel comfortable with China sending nuclear weapons into space? And would you trust them to do it correctly? There's a lot of uncertainty about whether you could actually come to an agreement about who is going to do this. And then what if you do break it into pieces? What if China does this, breaks it into pieces, and those pieces then hit the United States that's like hitting it with a bunch of nuclear bombs. Well, that's not good. And how would we feel about China in that case? Probably not too happy. And there's other people that would feel the same way about us. So there's definitely political issues with this, along with some practical things like the small pieces impacting. So most scientists would actually say this is what we would only do if we had no other choice, because this is the worst possible solution. Another thing that you could do, though, is try to divert it. You don't blow it up. You blow up the nuclear weapon somewhere off the surface of the asteroid. Don't actually slam it in there. That's less dangerous. You're not going to split the asteroid up into little pieces in this case. But a nuclear weapon, even exploding in the space around the asteroid, would cause a big enough force that you could change its orbit. Now, changing the orbit is a great plan. Then you just don't hit it all, and that's wonderful. That's what we want to have happen, is have it not hit at all. But if you want to successfully accomplish that, you need to know that it's coming, and you need to start this off pretty early on. You need to have a lot of lead time to prepare this. But there's still this whole political issue about using nuclear weapons in space. In fact, there are United Nations treaties that say that the countries of Earth agree we are not going to use nuclear weapons in space. Well, maybe if the survival of humanity is at stake, you might decide to put that treaty aside. But there are treaties that say we can't even do this. So you still have political issues whenever you're dealing with nuclear weapons. So the third option, which most scientists would consider to be the best choice, is to change its orbit by some other method. You see a couple of pictures here. These are artist pictures, of course. What if you get some lasers and you aim them all at the same place, and maybe you could melt enough of it and cause enough force, because light does have a force, that maybe you could change its orbit and it doesn't hit. So no problem. Another one is you can actually change the orbit of an asteroid just by having some gravity in the right vicinity. So get a really, really big spacecraft, get it up there near the asteroid, and you could actually use the gravity of the spacecraft to change the orbit of the asteroid. And that would work. Both of these things would work. However, number one, we don't have the technology. We could not do this in any reasonable amount of time with what we've got today. We just don't have it. We know how to do it, but it doesn't actually exist. We don't have this ready. If something were to be discovered very soon, we wouldn't be able to actually accomplish this. You need a lot of lead time. If you want to have something that's going to be capable of diverting the asteroid, but you don't want to have anything that's too big, you need a lot of time to actually get the orbit to change. And having enough lead time is an issue really with any of these, but having that much lead time, we're talking about years of time that you would need to know. And sometimes these things are not easy to detect. They're black rocks floating around in black space. It's not easy to find these things. You hear news stories all the time of ones that are, 100 meters across that are somewhere between the Earth and the Moon. Well, okay, those guys aren't going to hit us, no problem, but we find those a day or two before they pass between the Earth and the Moon. What if it's a bigger one? What if it's one that's going to actually hit? What if it's even just 100 meters and it's going to hit? That's still a nuclear bomb hitting the Earth. That's bad. A day or two is not enough time. Weeks are not enough time. You need years to accomplish something like this. So the lead time is a big issue. You really need to know what's coming, and then, of course, with these things, we still have to build them. They would be safe as far as life on Earth is concerned. So that would be great that they're safe. And there's no political issues with using something like this. The political issue comes with, should we go on and develop it now just in case? Because this would require billions of dollars. To prepare something like this is very, very expensive. And so you have to decide, okay, are we that nervous about something that we don't know for sure is going to happen anytime soon, that we want to spend that money and start preparing for something like this? Russia is working on that. They've decided to spend that money. The United States is not spending that money. So right now, if there were something like this that were going to happen, uh, chances are we would have to rely on Russia to solve the problem. So, up to you whether you trust Russia to accomplish it or whether you'd rather spend the billions of dollars and get ready, or you say, hey, I don't think it's going to happen anytime soon. It's going to happen eventually, but it might not be for 35 million years. I'm not willing to spend that money right now. So this is a political question. You should think about it, about what you would choose to do, what you would choose to do now. Should we prepare a system now, or should we wait until sometime when it's more certain that it's going to happen, but you don't have enough time to, as much time to prepare for it? So that's the question that we have to deal with.